Yo.
I wasn't here yesterday. Is there a paper or handout?
Yeah. Here. And, oh, real quick. Anybody not get the answer key for the factoring stuff we were doing? Anybody came in and didn't get the answer key? There we go. Somebody self-insulated this out. Oh. That's for the answers on the back of the other one I gave you. Everybody else good? Oh. And again, these are the answers for the ones that are on the back of the factoring methods handout. Okay. So if you haven't done all of these yourself, maybe don't look at this. So, for example, I might as well say this now. I'm going to give you guys practice tests, and then I'm going to give you answer keys. Unfortunately, some students don't try the practice test, and when I give the answer key, they do this. Yep. I would have done that. And then all that does is build false confidence. It's easy to agree with me. The whole point is, can you do it? I'm not going to do the test and say, do you agree? So be really careful when I give you a key for anything. Don't just stare at it. If you haven't tried the problem out, don't even look at this. Okay. Oh. These are answers for the background stuff. So let's get into the question. Let me build my way up to that level. That's kind of like the highest level of factoring that we're going to worry about. Can somebody help me out? How would I factor this? Nothing major, no tricks, just how would I factor that?
You take out the X?
How many x's can I take out? 2. Because they both have at least 2 x's. If I try to take out more than 2 x's, the first dude freaks out. Yes? So I call it the sort of nice tax guy. They might take all you have, but they don't take more than you have. And sometimes the real tax guy does. But so I take out, do you notice how I take out the smaller exponent? Do you guys see that? Doesn't that make sense? I'm always going to take out the smallest exponent. Because that's inherently what the other dude has. Is everybody with me? Okay. Now, what about, let's try this. Let's take one step up. Oh man, poor little dude. There we go. Yeah. Swap. What if I had this? It's different, but the general rule still applies. What power is smaller? So I'm going to take it out. Now, I want you to really, this is where you really have to analyze what the shit is. Everybody cool with that very first problem I did? Do you all agree that first problem was easy as shit? You're like, give me all of those, Jeff. I'm like, I won't do that. I'll give you something like that, but not a ton. Are you guys with me? Okay. Why did we put a 3 there where the 5 was?
Because that's all that was left.
Good. I took 2 x's away. So what do I do when I take something with a power out? What do I do with the powers? I subtract them, yes? That's how we got 3. You with me? Now this is, let me see. Very often we'll do some math and we don't even think about what we did. It's just kind of like that obvious. But you have to stop and think, why did I just do, why did I get what I got? Because that helps me when the math gets harder. I'm still going to do the exact same shit. It's just going to look different because the numbers are weird, right? Next thing we're going to do is we're going to throw some fractions in here, which is everybody's favorite. So what am I going to take out? X to the negative 2, because that's the smaller power. They both have some number of x's. Same as the first problem. In the first problem, we took out the smaller power. We're going to do it again. The first thing is easy. What's left if I take out x to the negative 2? What's left here? 4.
X to the 7.
X to the
7.
7th. How'd I get a 3 here? 5 minus 2 x's I took out leaves me a 3. What's 5 minus negative 2? 5 plus 2, 7. I need you to see how we did the exact same thing. So there's a phrase I use a lot when I teach pre-calc and algebra. Math doesn't give a shit what's in there. The process doesn't change. Does everybody see how the first and second problem are the exact same problem? The more you understand what I just said. Now some of you guys are like, dude, there's a negative on your 2. What are you talking about? You're insane. But no, those are the same problem. Just a number change. They're the same exact process. We care that all of a sudden I'm subtracting a negative and oh shit, I gotta remember that becomes a plus. Math doesn't give a shit. And you're like, I know math doesn't give a shit. No. The process doesn't care. I really want you to understand this. I do the same process. It's just harder because there's a negative number. Well, it's the same stupid thing. Okay, maybe. Let me stop for a minute. Anything freaky about what that second problem, how it happened? Do you guys see how it's exactly the same thing we did in the first problem? Exactly the same. Okay, maybe. All right, let me do this. Yeah, Jeff. How would I factor? Oh shit, Jeff. What the shit's wrong with you? You asshole. Well, I could have given this to you in a quiz, so I'm not as extreme of an asshole as it might seem. How many x's does the first term have?
1 to the m.
It's got m. Right? Like here, how many x's are right here?
5.
How do you know? It's got a 5. So how many x's are in this first term? M of them. It's 4 times x times x times x, and then however many m is. How many x's are in the second term?
M plus
4. Now, this is what I mean by students feel like you have to memorize each thing. No. What did we do in the very first problem? How did you figure out what to take out?
You count that in common?
How many x's did we take out in the first problem? 2. Why?
Because that would be
There was at least 2 on
There's at least 2 in each, and it's the fact that it's the smaller exponent that guarantees it's going to come out nice in the end. Yes? Real quick, let me see if you guys are cool. If I try to take out 3 x's, if I try to take x cubed out, what is 2 minus 3?
-1.
That makes the inside gross. So very often when we factor, we want to take the gross stuff out or the extra shit out and leave a nicer thing. We want to take the gross extra shit out and leave a nicer thing. Yes? So we took out 2, we took out -2 because that was the smaller power, so it's guaranteed to be in the other dude and end up nicer. So how many x's am I going to take out of this guy? M, because it's the smaller power, right? I need you guys with me. So if I take out x to the n, 4 here is the real MVP because what's left here? 4. How many x's are left here? I don't know why I put the 3 there, but I just did. How many x's are left here? How many m's? How many m's? How many x's did we take out? M. There were m plus 4, so how many x's are left now?
X plus 4.
4. If I take m away from m plus 4, I'm left with 4, yes?
Yes.
You guys with me?
Then we put an X on the outside, so shouldn't it be 3 now?
No. All right. How many x's did I put on the outside?
M.
Oh,
I put m. I took m x's away. That's why the first dude has no x's left, yes? Because I took all m of his x's. And the second guy had 4 more than m. So if I take m away from him, he's going to have 4 left. And again, what is m plus 4 minus m? M plus 4 minus m. 4. What is 5 minus negative 2? 7. For the first problem, what's 5 minus 2? 3. Whatever I take out that with a power, I subtract. Yes? Because that's how many of those things I'm taking away. When I take a negative out, I think of that as forgiving debt. And that's why minus and negative is plus. Yes? If I thought I owed $17,000 and then like, no, you don't. That actually happened to me with my car a while back. I was like, oh good, that's great. Now that's negative, negative makes a plus. Yay. Okay. So this would be 4 left. Yes? All 3 of those problems, if I just wouldn't have put the 3 there, are exactly the same problem. Just different numbers inside. So the process stays the same. Okay, let me stop for a minute. How are you guys doing? So now let me throw our favorite thing in the world in there. Get back. I get back. Yay, Jeff. Thanks, man. Somebody remind me what's a 1/4 power mean? I don't have to know that for this problem, but just because I threw it out there, what does a 1/4 power mean?
It's
0.25.
yeah.
That's what 1/4 can be rewritten as. What does a 1/4 power mean? Okay, real quick, guys, look. Let's change the square root for a second. If I take the square root of something, I'm cutting it in
Half.
multiplicatively, right? What are exponents based on? What operation are exponents based on? If I said, what's 7 squared, what operation would you do?
You times it by itself.
Multiply. You multiply by 7, because you have 2 sevens. Is that, you guys with me? I know what you mean. Exponents are based on multiplication. A square root means half of something multiplicatively. So if I want to rewrite the square root of x, we'll come back to the problem. I would write that as x to the 1/2 power. Does this sound familiar to anybody? Or if it doesn't, does it make sense? So here's my little rant. I wish we had never come up with freaking root notation. The square root is bullshit notation. I wish we had never made it. Fractional powers are so much better. Let me show you one reason why. This is going to be a little silly, but it's a quick. We know what the square root of 16 is, yes?
Yeah.
But then I just say I could rewrite it like this. And now you guys are probably like, well, that doesn't seem better, Jeff. But isn't 16 4 squared? Yes? Isn't 16 4 squared? And what do I do when I have a power and I raise it to another power? Do you guys remember what you do with the powers? You multiply them. What's half of 2? So the answer is 1/4. Isn't that what the square root of 16 is? So if I write it in exponential form, it's not memorization, which is sort of like what this is. It's just frickin' do it. Yes? It's something you can sink your teeth into instead of trying to like think of it all in your head. You can actually do it. And this is sort of like me showing you metric system. Is anybody familiar with the metric system? Could you show me how long a decimeter is? Okay, that's what I mean. You all could show me how long an inch is, yes? Do you all feel comfortable if I said, in the air, show me how big an inch is? Could you all do it? Could you all everybody do this for me. How long is a foot? Roughly. Okay. Nobody's doing this, thank the gods, or else I'd worry about you. You guys with me? If I say, how long is a decimeter? No. I appreciate that though. Well, let's see, a decimeter is going to be 10 centimeters. So you're about right. Yeah, you're about right. Okay, I like it. So do you know metric a little bit?
A little bit.
I like it. So we weren't brought up in the metric system. So this might seem like a strange suggestion because we weren't brought up thinking about fractional powers. We were brought up thinking about freaking roots, yes? But does anyone see how this, if you were brought up taught this, it's actually just you do the work, you don't have to like memorize or, all right, maybe, I don't know, yes?
Wait, the every other country doesn't use the square root notation?
No, I'm sorry. I was just making an analogy between a system we're familiar with and a system we're not. Yeah.
Oh, that baby, this is.
Every other country on the faces of the earth. Oh yeah, what'd you just say? You know that we're the only country left that does not use metric? There used to be 3 of us, and the other 2 were like, well, that's stupid. We're going to do it. And, anyway, sorry. I'm full of rants. I'm sorry. Okay. Hello. So if I have the cube root of x, does anyone know how to rewrite that?
X to the third.
Yeah, because the cube root is 1/3 of something. Multiplicatively, yes? Exponents are based on multiplication, so if I want 1/3 of something multiplicatively, I put 1/3 in the exponent, because that means multiplicative. Okay, made it. So, I just want to, if I was writing these, I want to make sure we all understand what they mean. In this specific problem, I don't have to worry about any of that. How do I factor this? You already know. It's the same problem again. It's exactly the same problem.
You take out x to the 1/4.
They both have x's, so I take out the smaller power.
Take out a quarter?
Yes, take out x to the 1/4. So again, our first term is the goat. It's the real MVP. What's left here? Holy shit. Now, what's left here?
X to the 4 and 4. Which is 1.
Yeah, it'll be 5/4. I had 5/4. How many did I lose? 1/4. So 5/4 minus 1/4. 4/4. 1. So I have a full x left. Would you all agree with me in each problem we did, the thing in parentheses is much nicer than what it was to start with? Okay, good. So there's 2 things going on. We take out the smaller power, because that guarantees both of the things have that in it. But the nice thing is that what it ends up doing is, I'm left with something really nice in the parentheses. How are we feeling? Better or... So you don't have to feel fantastic right now. Are you feeling a little better about that kind of problem? Okay. So here's the ultimate level. Get out. So I'm going to make finally kind of a different problem. 25w to the negative 3/5 plus 10w to the 2/5. Okay. Finally, a problem you would say is different. I would say it's the same problem. Math people were weird. We look at a problem based on what process I'm going to use to do it. The process is the same. One little extra thing though is, in the other problems we weren't worried about the numbers. I should worry about the numbers now, right? I always worry about them, but the other one was obvious. Nothing happened. What happens here? What can I take out?
5.
A 5. Good. So I can take a 5 out of the numbers. How many w's am I going to take out?
Negative 32.
Negative 3/5, because we know we always take out the smaller power. So you can do this first step, and you don't give a shit about fractions. It's just that's the smaller power. The next step, you're like, okay, let's see. And I was really nice here because I made the denominators the same. To be really honest, this problem happens a lot in calculus. A lot. And the nice thing is the bottoms are going to be the same. With me. Wouldn't this problem be so much worse if any one of the bottoms different? Because they ain't worried about like denominators in the middle of all this weird shit. The nice thing is, in calculus, when this happens, the denominators are the same. Which is so nice. It could have been so much worse. So, like you guys said, I'm going to take out negative 3/5 w's. So what's left in this first dude? Good. 25 divided by 5 is 5. I had this many, I took them all. 2.
W.
Good, because how am I going to do this? I took that many out. So it's 2/5 minus negative 3/5. 2/5 plus 3/5.
It's 5.
Sounds like a Dr. Seuss thing. 2/5, 3/5, right? 5th, 2/5. 2/5 plus 3/5 is 5/5 is 1. Again, do you all agree that what's inside the parentheses is much nicer than anything at the beginning? That won't always happen perfectly, but that's part of why we factor the way we do. Because, I won't go there yet. Is that okay? And pretty much who asked that question that got me on that? I think it was yes? Do you see how that directly applies to what they were doing? Okay.
They didn't explain the subtracting it at all, and then just showed up with
Yeah.
random exponents.
This is a free book, so sometimes they don't.
Yeah, I was looking at it and it was very confusing. I even wrote down the steps and it's like, am I missing something? And the answer is yes.
And that's one of my jobs, is to further explain things. I think this book does a really good job in terms of it because it's free. What really sucks is when you pay $180 and then make that kind of mistake with looking like, what the shit. Anyway, sorry. Anything else before I get back into what I want to cover today? Anything else? All right. And real quick, who just came in didn't get the answer key for the factoring problem? So this is the answer key for the back and the handout from yesterday. Okay. If there are no other specific questions, we're actually going to get right back into where we left off. And just to remind you guys, a question you could ask right now is, can we do another cubes problem? Do you understand? It doesn't have to be a specific question. You can ask anything math related. Okay. Yes?
So on the homework there was another one that had it was both of them were cubed and there was only one number in front of
Oh yeah.
the letters.
Do you remember which problem it was?
Yeah, it was 40.
How dare they? Let's see. Yeah, we've done a problem like this. What would you break this up into? B cubed is
Is it B times B?
BBB,
Okay.
And then-
right?
Okay.
And what's 8D cubed? It would be 2D, 2D, 2D. And then you can just populate the little and the big dude, yeah.
Okay, I thought so, but I got lost because I wasn't sure about there was no number in front of
Gotcha.
the B. Yeah.
Well,
Yeah.
it'd be negative 2D.
The way I do it, I kind of remember where to put the signs. You could break it up into negative 2D and then, yeah. There'll be a slightly different way to do it. You get the same answer. You're right. Yes.
So for question 56, it was the first time we're doing with something that's, what's the term for it?
No.
Okay, here we go.
I got an answer that works, but I'm not sure if it's factored down.
So how'd you start it off?
So I did the thing very similar to how I would do it with like the other cubes. So I put 81 goes into 3, 4, or multiple of 50 goes into 3, 4 times, and then 256 goes into 4, 4 times.
Oh, okay, real quick. I'm sorry. Okay. When there's two terms, what could it be? It could either be difference of. You do it. Two terms could either be one of two things, right? The problem we just did had two terms, and it was a cubes. What else could it be? X squared minus 25. Squares. It can only be squares or cubes.
Okay.
Meaning you try to cut everything in half or cut everything in thirds. So which one's this?
It would be
Half.
half. Okay.
You with me?
Yes.
So what's half of 81 multiplicatively?
9.
9. What's half of y 4?
2.
Y squared. What's half of 256?
16.
Yes. So in your calculator you can do square root of 256. Because that's definitely not a square we like know. Yes? Need you. Guys. When you're doing factoring, if you're like, I don't know what this shit to do with this, count the number of terms. 4 terms, you try group. 3 terms, you try, hope the first number's a 1 and then it's easy, or you gotta multiply and go from there, yes? Break it up into 4. 2 terms can only be cubes or squares. And of course, what do you always try first? GCM. Always take a second to make sure, does anything come out of everybody? Let me stop for a minute. Okay. Until you try to do some of these problems, you're not gonna know if you can do it or not. Yes.
So was this correct? Because I got this and then I'm like, I could factor this one.
Yeah, totally.
Oh, so I got it
You gotta
right?
do two steps, yep.
Oh, wait, so it's
This
like.
one, no, I'm sorry. This one's fine, because you can't factor
Yeah.
some. This one goes for, yes.
Okay, oh, awesome. I guessed it right.
In general, if you have a fourth power, it might go 2 times. Yeah.
Yeah, because I initially tried the one thing and it didn't work. So I tried it, like, what if I just do it this way?
Gotcha. And the great thing is this is, alright. One thing I have students tell me is I assign too much homework. And apparently I don't care because it keeps assigning. So let me say this, I kind of forgot to say this the first day. And again, we did the whole jobs thing, people with jobs, so forth. Even if you don't have any jobs, you probably have obligations, family obligations, whatever, yes? I'm a big proponent in making homework your own. You guys remember how I said I never finished homework? Do you guys remember that? I was very honest with you. Because I just physically couldn't. So what did I do? I did enough of it so I felt comfortable with the idea. Right? Now listen, if you turn in incomplete homework, I'm going to tell you to finish it. On your end, you're going to be like, dude, this is what I could do. I'm going to give it to you and leave you alone. You guys kind of with me? Make homework your own. What I don't like is when students are like, I didn't have time to do all the homework, so I didn't do any of it. What the hell sense does that make? Do what you can. So what I say is if you start getting behind, start doing every other problem that I assign. I am not telling you that I'd be cool with it. I'm not telling you you're gonna get full credit. I am telling you the most important thing is to get practice and do well on a test, because that's the heaviest weighted thing, yes. Hell yeah, please do. That makes it so much easier for me to grade it. So- No, nothing's due yet. Is anything late yet? When is the first time something's late?
After the exam.
After the test, yes, right? And a quiz is not a test, so I always get somebody, is it due today or no? We haven't talked about a quiz yet, so you're fine. Is everybody with me? Okay. I don't know if students really know, I try to be very transparent with students. This is your education. I assign homework problems because I think that's how many you gotta do with enough different types of stuff so you really get comfortable. You say, well, I can't do all that shit, Jeff. I'm gonna do as much as I can so I can get practice, so I can be ready. Do you guys follow? And then you finish it if you can. And if you can't, homework is not worth enough to kill you by itself. Homework is enough to kill you if you don't do it. Okay, maybe. Students never quite understand what I'm trying to say, but hopefully that makes sense. Okay. Yes?
So when is the last, like, when can we get full credit before, like, if we turn in.
Anything you give to me by the day of the test.
That's
So if
full
you give
credit.
me all the homework on the day of the test, please try not to do that. But if you do, that's fine, technically fine. Everything's on time. If you give it to me the next day after the test, it's a little bit late. And I normally don't really if you turn in one thing really late, or if you turn in a lot of stuff late, that's when it's gonna really hurt you. So if you come to the test, you're like, I didn't finish that one section, I'm like, give it to me next time. Not a big deal. If you're like, I didn't finish chapter one, I'm like, holy shit, that's not good. Give it to me as soon as you can. Are you guys with me? Okay. In a perfect world, I wouldn't collect homework. There was one semester, my second semester teaching, I didn't collect homework. What do you guys think happened on the day of the test? The first test. Everybody failed. Every single student failed. Because I didn't make them do homework. Well, a couple people passed, I think. You're all human. If I don't make homework due, are you taking other classes? Is the homework due on those other classes? Aren't you going to focus all your attention on those? Okay. So I have to make homework due. Yes? So hopefully some of you guys understand what I'm trying to say with that. Do as much as you can. Do all of it if you can. Shit, yeah, it's the best. Okay. Remember what got me off on that? Tirade though. Okay. Anything else before we? Did I forget somebody's question? Anybody? Okay. All right. Last time, I think we barely started talking about complex numbers. So what I want to do is I want to kind of very quickly go over what we've done so far, show you a couple of results of what we've done. I'm not going to totally read this, but remember multiplying by -1? was like a 180-degree turn? Yes? 1 times -1 is -1. -1 times -1, another 180-degree turn goes back to 1. Is that cool? That is physical, by the way. That is the truth. That is the reality. Yes? So then, in history, we said, well, what if I go halfway? That would be half of -1. Yes? Multiplicatively, because this is all about multiplying. And that's what we give the letter I. Just because it's freaky. It freaks people out, so we just give it, we call it I. So is I a variable? No, because it's not allowed to be anything. It's specifically that. It's sort of like the pi. Okay, maybe. Somebody semi with me. We started talking about this yesterday.
So it's always square root of -1.
I is always the square root of -1. So something that immediately comes out of this, if I multiply by square root of -1 again, where do I end up? So this is times I. Where am I at now? -1. So what is I times I? -1. So I squared is -1. That's the first mathematical object we've encountered whose square is negative. You've never seen that before. Does this sound familiar to anybody? Has anybody done any work with I before? Yes? Okay. Yes?
I think this is probably from earlier, but what does it mean when an exponent is negative? Like, say there's 2 to
Oh.
-2.
Okay. Let me take that little side trip real quick. Everybody's just freeze frame on this, yes? Real quick. Real quick. What does x to the 0 mean? Why?
I don't know why.
You ready? What do I do when I divide like this? What do I do with the powers? Subtract. So wouldn't one way to get 0 power be like this? Do y'all agree that would be x to the 0 because 7 minus 7? But what is something divided by itself? So x to the 0 is 1. Yes? Anything to the 0 power is 1 except for 0. This is all I'm going to say. 0 to the 0 is weird. You talk more about it in calculus. That's all I'm going to say about that. So anything else, almost anything to the 0 power is 1. You guys with me? And real quick, this is silly. What does this mean? What does that mean? X times x. There's 2 x's, correct? What's in front of it? What's understood to be here? Good. Now, if I lose an x, I got 1 x there, yes?
Yeah.
And the 1 is still there. What if I lose 1 more x? What's the only thing left? 1. I don't know if you guys follow. That means x to the 0 means you have no x's, you just have that 1. So that's another reason why x to the 0 is 1. One more reason why is, what do you multiply something by to make it stay the same?
1.
You multiply by 1. What is x to the 0 times x squared? What do you do with the powers?
You
Add them. So what do you get?
x to the 6.
I multiplied something by x to the 0 and it stayed the same. What's the only thing that does that? 1. So what does x to the 0 have to be? 1. Okay. My man over here is like, I asked about negative. I know. So now we know how to investigate x to the -1. How do I set up a division problem where it comes out to a negative power? You already told me you subtract when you divide. Can you come up with a power on the top and the bottom so the power at the end is -1? You can do it. If the top was x squared, what would the bottom have to be?
X -3.
No, don't overthink it. 3. 2 minus 3 is? -1. Now, is everybody with me? How many x's, if I look at this a different way and I reduce this, what do I get if I reduce this? How many x's cancel? 2. How many are left?
1.
Where?
On the bottom.
So what does a negative power mean? It means flip.
So 2 to the power of -2 would be 1/4.
Yeah, 2 to the -2 would be 1 over 2 squared would be 1/4. So whatever it normally would be, what's 3 cubed?
27.
27. So what's 3 to the negative 3? 1 over 27. So all a negative power does is flip something. Why? Because of that shit. We just proved it. You guys kind of with me? Okay.
I guess I'm thinking about something that we don't have to worry about just yet.
No, this is everywhere. So it's not a bad question. This could show up anytime it
I
wants
guess,
to.
well, what I was worried about was before that you had a problem with w to the negative 3/5. So
I'm
I
with you.
wasn't sure what.
So I talked
now
about
that I know
fractional.
what fractions are and negatives are, now I gotta combine the two and think about like what a negative.
So like 9 to the negative 1/2 would be 1 over 9 to the 1/2, which is 1 over the square root of 9, which is 1/3.
Okay.
So the negative power just gives me one more step. Whatever I normally would do, I just flip it.
Okay.
Okay. Coming back to this. Oh boy. Okay. By the way, just to remind you guys, about 9:05 or so, we're gonna take a little tour. All right. So I'll ask us all to pack up then. I'll try to keep an eye on the clock. Okay. I really want this to just, it's really unfortunate, the name. I think I told you. I'm going to show you a little video here in a second that is one of the coolest little videos. We'll see if you agree. You don't have to agree. You can hate it. That's okay. But the funny thing is, I never was taught this. I was never taught this. I discovered this later after I started teaching, that this makes sense. And then there's future math stuff we do that if you know this, that shit makes more sense. And I'm like, that would have been nice. But this is all it physically is. This is it. If I go a full 180, that's multiplied by -1. If I go halfway, that's multiplied by half a -1. Not a major deal. So let's keep going. What if I multiply? So I squared is -1, yes? If I do 2 i's, since I is a quarter turn, I get to -1. What if I do one more? By the way, real quick, right here, this is I. Because that's where I am at that point, yes? So what do you think this is? Negative I. So what would I times I be? Where am I? Negative I. So I cubed is negative I.
Would negative I be positive 1?
Hold on. We'll get there. No. Negative I is just negative I. Because it's the square root of -1. There's another way I can look at this. What's I squared?
0.
-1. Right? If I do 2 quarter turns, I end up at -1, so I squared is -1. So what's I squared times I? That's -1 times I. What's -1 times I? That's -1 times I. Negative I. Yeah. -1 times anything is negative that thing. Yes? So I could get this answer not visually, I can get this answer just by multiplying both sides of this by I. Do you guys see that? All of math has to act that way. There must be multiple ways to get to a result. So it's self-consistent. Okay, maybe. Does this sound familiar to anybody? A little bit? Okay. Not really? Screw you, Jeff? Okay. So you're not going to believe what I'm about to do. What if I go one more I? Where do I end up? Where do I end up? 1. And sure enough, if I multiply I cubed times I get I to the 4th. If I multiply negative I times I, what is negative I times I? Well, what's I times I? -1. So what's negative I times I? Positive 1. There, we can get the same result 2 different ways. Maybe. The most important thing up here right now is I squared. That is what we see the most often. Yeah. Now some of you guys might realize, can anyone tell me what I to the 8th would be?
2.
1. Because you just go all the way around twice, yes? So here's the trick, ready? If I divide the power by 4, it tells me, the remainder tells me where I am in this cycle. Do you guys see how this is a cycle? 1i, negative 1, negative I. 1i, negative 1, negative I. So if I do I to the 12th, 1, 2, 3, I'm 1 again, yes? So if it goes, 4 goes into an even, it's 1. If I want to know what I to the 20, you can do it, Jeff, 21st power is. I to the 20th would be 5 rotations, and then how many more times do I go? 1 more I, so the answer is I. 4 goes into 21. I don't give a shit. What's remaining? What's the remainder? 4 to 21 has remainder what? 1. So I to the first is the answer. So if I divide by 4, it tells me where I am in the cycle. Everything I just said is not quite as important as I squared equals negative 1, but it's still good to know. Okay, I love it. Now, do you want, yeah, let me do this. Let me show you this video so I can shut up for a moment. It sounds very exciting, yes? I have to remember to stop recording so I don't get copyright strike. All right, be quiet.
Did you stop recording?
Oh, thank you. All right. I very much appreciate that. I said it. And you're probably like, probably in the worst way imaginable, John. No. Okay, every number we've ever seen. Can somebody give me your favorite number?
2.
That is a complex number.
17.
It's complex. Huh? 5 is complex. I'm sorry. Every number you've ever seen is a complex number. We just didn't call them complex because a complex number is a real number plus an imaginary number. And let me show you the form it's in. And some of you guys might say, well, 2 is not that, Jeff. Yes, it is. A complex number. Oh, sure. It's always good to have somebody speaking up when I do weird shit. Complex number is in the form a plus bi. So every number you've ever seen, the value of b was 0. If we make a 2 and b 0, that's the number 2. Does that make sense by itself?
So the formula for every complex number is whatever the number is
The
plus 0
form
times
of a
the
complex number, any complex number is that. If b is 0, it's purely real. If a is 0, it's purely imaginary. So here are some complex numbers. 7i. What's the value of a?
7.
No. What's the value of a?
0.
0. What's the value of b?
7.
There you go. So it's purely imaginary. 7 imaginary units, right? 2 is a complex number. The value of a is,
2,
the value of b is 0. Here's a more interesting complex number. 5 minus 11i. That's complex. A is 5, b is negative 11. Are you guys at all with me? And, well, we'll get there. Okay. The most basic stuff you could do with complex numbers. So for example, here's one complex number plus another complex number. And what do you get? No, yes, don't over freak out. It's 2 plus 7. You're finally learning that those numbers are part of a bigger group of things. We didn't tell you that before because you didn't even know imaginary numbers existed, so why would we? Yes? I'm sorry. I'm so sorry. I'm using this as like Roman numerals, but you got a really good point. Okay. I'm so sorry. I gotta be more careful when I talk about imaginary numbers because it's a little trippy. What do I mean? What is I? And then you start grammar, it's weird. So a more interesting set of complex numbers to add would be 5 minus 11i plus 6 plus 3i. What do you guys What's your gut tell you the answer is to this?
11.
Okay, 11. Keep going. Minus 8i. So it's exactly what the shit you would hope. I acts like a variable because you're just collecting how many i's. Now, to be really honest, what does 5 really mean? 5 ones. 5 means 5 steps of 1, yes? So 5 ones plus 6 ones is 11 ones. Negative 11 i's plus 3 i's is negative 8 i's. All you're doing is you're collecting all the real stuff and all the imaginary stuff. How we do it? That kicks ass. Well, thank the gods. So here's where things get a little trippy, and here's why I said earlier what I said about what the most important power of I was. How do you think I do this? Yeah, go ahead, do it. I'll wait. Do it. Do it exactly the way you'd hope it would happen, and you'll be right. Of course, you go like, I wish it would happen this way, where it just goes away. No. Now, normally, if I just had a true variable like x, I would have one more step. Since I have I, which is not a variable, I have 2 more steps. You guys see what those 2 steps are? Kind of technically 3, but we'll go okay. What's one thing you can do immediately, right in the middle? Yeah, negative 4i plus 15i is?
9i.
Who?
11i.
11i. And what else can you do here?
Negative 10 times negative 1.
Yeah, what's I squared?
Negative 1.
Okay, you guys see that? You guys see that? So this becomes 6 plus 11i plus 10, so it's 16 plus 11i. How about you, Bob? Y'all look very excited. So anytime you've ever multiplied 2 numbers, you actually multiply 2 complex numbers. Thankfully, they had 0 imaginary parts, so it was easy. So there's one extra step here because I is not a variable. You can go one extra step because you can simplify I squared. Okay, maybe crop it.
There's one extra step after 16 plus 11i.
Say again?
There's one extra step after 16 plus 11i.
What would that step be? Can you put those together? Are those like terms? No, that's it. That's why I circled it. Yeah, you can't put those together. No, not like terms. Does I equal negative 1? No, hell no. I squared is negative 1. What's I?
Square root of small.
Square root of negative 1. So yeah, I agree with you. Just leave an I. Don't do shit. Because this is square root of negative 1, which is trippy. But I get people start to replace I with negative 1. It makes things easy, but it makes them wrong. So don't do that. Yes?
Will there be a chance where it's similar to that ending, but it ends in a way where, say, you have I, but you can change it to a square root of negative 1 and then simplify it even further?
No, because you can't do anything with the square root of negative 1. You see? That's why it's okay to keep it as I. It's sort of like, what if you replace pi with its decimal representation? Do you want to? Because it never ends. But it wouldn't do anything for us. You wouldn't be able to do anything extra with it. Yeah, same thing here. Yeah. But it's a good question. I mean, you want to simplify shit. So you're like, can I go further? No. Okay. Okay. So, we've added. You can subtract 2 complex numbers. You still get your like terms together. You can multiply 2 complex numbers. Was the only thing we haven't done.
Okay.
We've added, subtracted, multiplied.
I'll divide.
Okay. So let me see. We have so little time. Recall. Does anyone remember how to rationalize this? This is not rationalized because the bottom is irrational. Does anybody remember how to rationalize this? This is really important. When we get to trig, you're going to be doing this a lot.
Do you multiply by the reciprocal or?
No, that would change the problem. I can't change the problem. I can multiply top and bottom with them. Now, let me ask you this real quick. Why can you not do the square root of 5? It's kind of a dumb question, but I won't. Why can I do the square root of 25, but I cannot do the square root of 5? What does 25 have in it? 2 5s. You with me? And the square root needs how many things in it to be able to be done? 2. I can do the square root of 16, because 16 has 2 4s. I can't do the square root of 7, because 7 ain't got any nice anything. Yes? How many more 5s does the bottom need so I can do the square root? 1 more 5. Let me give the dude 1 more 5. Let me give it to him. I love you guys so much. So if I multiply the bottom by the square root of 5, and I have to multiply the top by the same thing to make it legal, yes? The top does the top become square root of 15? Shit, no. Because I got a full 3 times half of 5. Those can't go together. You can only multiply and divide it. They're the same root. And 3 ain't got no root, just to be grammatically wonderful. So the top just becomes 3 rad 5. Now the bottom, if you want to do it the long way, what is the square root of 5 times the square root of 5? It's the square root of 25, which is, quick way is, half of 5 times half of 5 is a whole freaking 5. Right? Now, is the bottom rational? Does anybody remember what rational means? It could be written as a fraction. The bottom could be written as 5 over 1. Rational. So we rationalize the denominator. Does this sound familiar to anybody? Now, 2 more things and then we'll go on our tour. How do I do this weird shit? What do you got, Jeff? Sure. Oh, shit. If I multiply the bottom by square root of 3, the 4 picks up the square root of 3. It's not rational. Yes? I love watching some of your reactions when I put up some of you guys are like, does anyone remember what to do here? So did you guys see the problem? If I multiply this by square root of 5, it just attacks itself. Square root goes, if I multiply this by the square root of 3, I distribute. He picks up a square root of 3. Shit! So here's the trick. Do we have something where the middle terms cancel? Does that sound familiar? Middle terms cancel. When I multiply like a difference of squares kind of thing. So if I multiply top and bottom of this by 4 plus the square root of 3, that's what's called the conjugate. I don't care so much about words as I care about process. So if you forget the name, but you're able to do it, beautiful. Do you guys see what happens? 4 times 4 is 16. Half of 3 times half of 3 is 3. Those are both rational numbers, yes? They're not radicals. And then the middle term is the only place a radical could be, but how did we set it up? We set it up so that the middle term cancels. So the result is going to be rational. So I get, on the bottom I get 16 minus 4 of these plus 4 of these, so screw them, minus a full 3. And the top is just going to be gross. Too bad. 12 plus 4 rad 2 plus 3 rad 3 plus rad 6. Just distribute. Is that cool? Just FOIL it out. So the bottom is 13 and the top is a bunch of shit. So why am I talking about this when we were just talking about complex numbers? Because this.
Is there a root around, is that like a 6 or a 16 at the end of the column?
Hold on, it's a, oh crap. It's a square root of 6. Right, square root of 2 times square root of 3. Half of 2 times half of 3 is half of 6. Square root of 6, yeah. So what do I do if I have this? Do you see how that's the same kind of problem? Because what is I? Square root of -1. It's just radicals.
So then you
So what would I multiply top and bottom by?
5 plus 3.
5 plus 3i. Now, a bigger thing is, if I divide two complex numbers, the answer has to be a complex number. Does that make sense? If you divide two numbers, you get a number. And every complex number looks like a plus bi. So I have to be able to write the answer in the form a plus bi. So if I multiply by 5 minus 3i, I'm sorry, plus conjugate on the top and the bottom. On the bottom, I'm going to get 25 minus 9i squared, because the middle terms cancel, yes? And on the top, I'm going to get, just to do this a little quickly, plus 21i plus 10i plus 6i squared. And then what do you think my next step is going to be? What's I squared? Negative 1. So that becomes 25 plus 9. And up here I get minus 6, yes? And then I could put these together. I went a little longer than I wanted to, so I want to go quickly. So, guys, I'm really sorry. we have to go. Get everybody. And if you have questions, I have office hours right after this, so you can hang out with me afterwards. Pack everything up. We're going to go by the Mass Science Center. Can you guys do me a favor? Start to walk that way very slowly and wait for me to run in front of you. It's going to take me a second to pack up.
Where do we turn in homework?
Should we take our
Right here.